Welcome back to Aurora Tech Channel. Today, I will be reviewing this GeeeTech Thunder 3D printer. This is a bed slinger that claims to be able to print at 300 millimeters per second with 5,000 millimeters per second squared acceleration. This printer doesn't run Klipper or Marlin firmware, and instead, it runs a self-developed firmware called Smartto. As you may already know, Marlin can run on a slow processor, and even an 8-bit ATmega 2560 on the Prusa MK3S Plus can run Marlin pretty well. But it prints really slowly, as all the calculations and the stepper motors, limit switches, as well as other components are controlled by the same slow processor. While Klipper needs a faster processor like a Raspberry Pi, Sonic Pad, or a BigTreeTech CB1 Raspberry Pi alternative board to run and do all the printing calculations, you can use the slower processor on your motherboard as an adapter to control other components. The Smartto firmware uses a regular 32-bit Cortex M3 72 MHz processor to control the components of the printer, and uses another 168 MHz Cortex M4 processor for the calculations. The other hardware aspects of this printer are also quite interesting. The printer uses an extra large heated block with an extra long tip, similar to a volcano-style nozzle. It has dual 50-15 blowers on the print head and two 60-20 large fans at the back to provide extra cooling. It uses closed-loop stepper motors on the X and Y axis. It has silent stepper drivers, auto bed leveling, a dual Z-axis, belt tensioners on the X and Y axis, and a unique Y-axis design. The extruder is a BMG clone with a Bowden setup. I would like to thank GeeeTech for sending me this machine to review, and with that, let's get started. We have the base, a PC spring steel print surface on the heated bed, a 200-gram roll of sample filament, a 3.5-inch touchscreen, the gantry with the Bowden-style extruder and print head, the user manual, and some tools. There's a 3D touch inside the toolbox, so I will install it on the print head first. Then, I will put the gantry on top of the base and use two M5 screws to secure it at one side, and then flip it and secure it at the other side. Install the side brackets to reinforce the gantry, starting with the right side, and secure it using 8 M5 screws. Do the same to the other side. Connect the ribbon cable of the screen before securing it at the right side. The filament holder is installed on the same side. Now, let's connect some cables, then flip the switch of the power supply to match your local voltage and turn on the machine. When I insert the microSD card and turn on the machine, the screen doesn't show anything. Once I remove the card, the screen works normally. When I reinserted the card, the screen has no response once again. I assumed there may have been some issues with the format of the SD card, so I took it to the computer and reformatted it. For now, I will use the printer without the SD card. The screen menu is very clean. Let's start by leveling the bed. It's not under the Prepare section, but rather the Operate section, so select Leveling there. Since this printer has a 3D touch, just click Start to begin auto bed leveling. When it homes the Z-axis, you can see the two limit switches on the dual Z-axis will also level the gantry, and this is followed by a 16-point probe on the bed. Next, use the up and down arrows to move the nozzle down and set the Z offset. I will now feed in some filament. The filament loading menu is quite handy, as it can keep moving in one direction to feed in filament until you purge out the previous color. Let's go to Cura and slice some models. The SD card already comes with Cura 5.1 and the printer's profile, so we can just select Thunder from the list. I created a few print profiles from 50 millimeters per second to 250 millimeters per second with different accelerations. Let's take the slowest 50 millimeters per second profile. The print speed is 50 and the first layer speed is 25, and similar to the profile on an Ender 3, the acceleration is set to 500, so we can print a standard speed 3D Penji as a baseline and see how the quality changes when the print speed increases. Okay, this 50 millimeters per second profile will take 1 hour and 38 minutes, which is slightly faster than the Ender 3's 1 hour and 50-minute time. The print ended up taking 1 hour and 33 minutes, which is 5 minutes faster than Cure's estimated time. The Benchy is alright, but there is some salmon skin on the surface, which normally only shows up due to non-silent stepper drivers. As the print head has two 50-15 blowers, I'm not sure if it was caused by the vibration of the fans. Besides that, the layers cooling and overhanging are all normal. Next, I will print a Benchy with the 250 millimeters per second profile. The infill and travel speed are 250, the speed for the walls will slow down to 100 and 125, and the first layer will print at 50 to make sure the print sticks well. For acceleration, I will just set everything to 3000. The estimated printing time is 42 minutes, so let's see how it turns out. The Benchy took 44 minutes. Compared to the one printed at 50 millimeters per second, the surface of this 250 millimeters per second Benchy still isn't too bad, other than how the surface isn't as clean as the one that was printed slower, and the plastic in this area shrinks too much. The cooling on both Benchys look good, and these results really aren't bad, considering that they were printed by a bed slinger printing at such a high speed. But the 44-minute printing time seems a little bit too long. As I saw on their website, they were showing a 21-minute Benchy. I asked GeeeTech for that G-code file to see if I could print one at that speed as well. In their G-code file, the orientation of the Benchy is different, as it's flipped 90 degrees and the Z-seam is right at the front. This probably isn't how I would normally slice a Benchy, and as you can see, the layer lines are thicker than normal, so I also don't think this is a 0.2 millimeter layer height, but we will find out for sure later. The print finished in 26 minutes. As this was printed in normal mode, I will then use the fast mode to boost the speed up to 125% and reprint the same file. Using fast mode, a very similar Benchy can be printed in 20 minutes. Finally, I will use crazy mode to boost the print speed to 150% and then compare the print quality with all of the different print modes. Using this crazy mode, the Benchy finished printing in 16 minutes. As you can see, as the print speed increases, the quality decreases. Take a look from another angle. The cooling of all three Benchys is fine, but these areas obviously get worse when the speed goes up. A 16-minute Benchy is really fast, but all you can expect from this print speed is a very rough prototype. I also inspected the G-code, and it was sliced at a 0.3mm layer height with a line width of 0.48mm, so when you print at a 0.2mm layer height and a 0.4 line width, you may not be able to print a 3D Benchy this quickly. Next, I will print a calibration cube at 250mm per second and 3000 acceleration using normal mode, which means the printing speed isn't boosted and is just at a regular 100% speed. The cube finished in 11 minutes, which is almost 3 times faster than a normal cube that would take 30 minutes. The surfaces don't look too bad from here, but there is some ghosting on the surface if we look at it from another angle. The dimensions are fairly accurate and are still within an acceptable range. Sticking with the 250mm per second profile, I will print a model of St. Basil's Cathedral. This print took 6.5 hours to finish, and the result looks alright. The tiny tips on the towers are not that great, but considering that a standard Ender 3S one printing at 50 millimeters per second would take 15 hours, overall, this print isn't that bad. Then, I will print this model of a jet at the same speed and 3000 acceleration. This print finished in 1 hour. The quality is decent. These areas are the Z-seam, and the seam line is a bit obvious. The surface is not as clean as what you would expect from a normal print. Up next, I will print a light switch cover. This is very simple geometry, and the print finished in 1 hour and 22 minutes. This time it turned out pretty nice, and I can't see a huge quality loss. If it prints one on a PEI sheet, the surface should look even nicer. After that, let's try using vase mode to print a bowl. Even when using vase mode and a 0.3 layer height, this bowl will take more than 2.5 hours to print if we were using a normal 3D printer. So let's see how fast this Thunder printer can finish the print when printing at 250 millimeters per second. This model took exactly 1 hour, and the quality is pretty good. The only part that's not perfect is the bottom. If you look at it from the inside, it's a bit rough, but besides that, I am okay with the result. Then, I will try printing with PETG. As PETG can't be printed as quickly as PLA, I will slow it down to 80 millimeters per second with a 1000 acceleration. This print finished in 2 hours. Since the print speed is not that fast, the quality is in line with PETG printed by other printers. I don't have any complaints about this print. Next, I will print some ABS for a filament holder for my printer rack. For an Ender 3S one at 50 millimeters per second, this print would take 5.5 hours. So let's see how much faster we can print with the Thunder. I will try to print at the same 250 millimeters per second, and it estimates that it will only take around 1.5 hours. I'm actually not worried about the speed, as ABS can be printed as fast as PLA, or even faster. But let's see if this print surface can stick well to ABS when the bed is swinging so fast and without an enclosure. Unsurprisingly, the print failed because it didn't stick well to the bed. So I applied some glue and restarted the print. This time the print finished in 1 hour and 32 minutes, and the result is pretty good. The surface is not very smooth, but for functional parts with simple geometry, I would rather have a print with usable quality that was printed in just 1.5 hours instead of a perfect model that took 5.5 hours. Finally, I will print some TPU. I will print a model of a Snorlax, a Pokemon species. I will print the model with Area 1 TPU using the same 80 millimeters per second profile with 1000 acceleration, just like how I printed PETG. The result seems pretty good, and the Snorlax is also pretty squishy. Okay, let's talk about the pros and cons of this printer, starting with the pros. 1. This printer uses 2 processors on the motherboard. One 168 MHz processor is for calculating high-speed printing, and one 72 MHz processor is for the rest of the components. Combined, the result is alright, and it works sort of like Klipper, but not exactly. I will talk more about the firmware in the cons section. 2. The printer uses closed-loop stepper motors on the X and Y axis with greater torque, which prevents skipping steps that may cause layer shifts. 3. The cooling system is the strongest I have ever seen. It uses dual 50-15 blowers on the hot end assembly and two extra large 60-20 fans at the back that you manually turn on and adjust the speed for using the screen menu, so it can provide any level of cooling that you need. 4. The hot end, a large size heated block, and a 70-watt heat cartridge can melt filament fast. The nozzle has a long thread that is the same as the volcano nozzle, but the tip of the nozzle is even longer, which can prevent the cooling fans from blowing directly on the heated block, which is a very smart design. The Bowden setup also works fine, as the main purpose of using a Bowden setup is to make the print head lighter in order to print fast. 5. The base is nice and heavy. Additionally, the belt on the Y-axis is a 10mm belt instead of the regular 6mm belt, and there are two brackets to reinforce the gantry. So when printing at high speeds, the frame is more sturdy and shakes less than other Cartesian bed slingers. 6. There are dual limit switches on the dual Z-axis controlled by two stepper drivers to sync the gantry every time you home the printer. 7. There are no more leveling springs and knobs on the four corners of the bed for manual adjustment. It just lets the auto bed leveling sensor do its job. 8. The print surface works really well with most materials. It sticks well to PLA, PETG, and TPU, but this wasn't the case for ABS, as it didn't stick well without applying glue. Now for the cons. 1. The concept of GeeeTech's self-developed Smartto firmware is similar to Klipper, as previously mentioned in the pros section, which does work, but I can't see how I would be able to connect an accelerometer to measure resonance frequencies like you would to calibrate input shaper in Klipper. For example, the surface of the 3D Benchy, as well as the ghosting on the calibration cube, is not that great when printing at 250 mm per second with 3000 acceleration. If the printer allowed input shaper recalibration like Klipper, I believe the surface quality could be improved. 2. This printer supports a USB drive and a microSD card, but it doesn't support Wi-Fi printing, unlike other Klipper firmware machines where you can use the main sail or Fluid Web UI to control the printer, or use the Moonraker plugin in Cura to send print jobs directly from the slicer. 3. It doesn't come with an all-metal heat break, so the maximum nozzle temperature is limited to 250 degrees Celsius. This is still good enough to print PLA, PETG, ABS, and TPU, but an all-metal heat break and a better thermistor won't cost much, so I would definitely like to see this printer print a broader range of filament. 4. For a self-designed screen UI, it works pretty nicely. However, I would like to suggest adding a number pad, so when you adjust the preheat temperature, you can just enter in the number without having to use the plus and minus buttons. Additionally, the main menu only has 4 buttons, so it would be nicer to show the nozzle and bed temperature at the bottom or top of the screen as well. 5. The cable management has some room for improvement. As it currently uses separated cable looms to run the cable from the base to the X-axis, the cable management isn't even as good as some entry-level 3D printers, so I would like to see GeeeTech do more in this area. 6. The print bed itself sticks pretty well to the prints, but the sticker of the magnetic base does not stick well to the heated bed, and it lifts when you remove the print surface. This is very unlikely to happen, even with some cheap 3D magnetic bases that I bought from AliExpress. In conclusion, this printer does print quickly and is definitely capable of printing at 250 mm per second with 3000 mm per second squared acceleration with presentable quality. And it can print 300 mm per second and 5000 mm per second squared acceleration, but like these Benchies in fast mode and crazy mode, I would just call them a rough prototype. Even at 250 millimeters per second, the quality may not be as good as those printed at 50 to 60 millimeters per second that took 3 to 5 times longer. But if you are okay with this presentable quality for decorative parts and usable quality for functional parts, you should be happy with this printing speed. The hardware is good, and the cooling system is one of the best I've seen. The closed-loop stepper motors on the X and Y axis and the design of the Y axis also work better than other Cartesian bed slingers. The hot end is able to melt filament fast to keep up with the print speed as well. But one thing I don't really understand is why GeeeTech needs to develop its own firmware when open source firmware like Klipper is available for free and works very well, so making a similar one with fewer features doesn't make the most sense to me. The only advantage I can see from this Smartto firmware is that it runs on a slower processor like the Cortex M4 168MHz processor that comes with the printer. This is a very good solution as not everyone can get a Raspberry Pi to run Klipper, but now there are many Raspberry Pi alternatives in the market like the $30 BigTreeTech CB1 board that comes with a 1.5 GHz processor and 1 GB memory, which is more than enough to run Klipper, so this actually won't cost much. The hardware of this printer is pretty good, but it would be even better if there was a Klipper version of this printer that supports Wi-Fi and could use a web interface like Mainsail to control the printer and monitor print jobs, has an accelerometer for input shaper calibration, and also improves on the other points I mentioned in the cons section. The MSRP of this printer is $699, which is not a very attractive price, but this printer generally sells at around $500 and is now on pre-sale for $489, which is reasonable. If you are interested in this printer, I put the link under the description. That's it for this video. If you like this video, please hit the like and subscribe button. And make sure to hit the notification bell to receive new video updates. I will see you next week.